So our Honorable Vice Chancellor, sir, is already with us, and we are already having our keynote speaker, Professor Bianchini. Sir, Vice Chancellor, sir, can we start now? Can you hear me, sir?
Yes.
Okay. Thank you, sir. Thank you. So I welcome you all on behalf of the organizing committee for this National Librarians Day, which we celebrate every year in the loving memory of the birthday of Dr. S.R. Ranganathan, who is considered as the father of library science in India. So myself, Partha Mukhopadhyay, and my colleague, Dr. Deepa Rai, welcome you all on the auspicious National Librarians Day 2022. This international webinar on the theme Ranganathan and Retrieval is inspired by our Honorable Vice Chancellor, Sir, Professor Manoj Kumar Sannal, who always encourages us in improving the library services for all the stakeholders. Our central library is going to get a whole new building, an RFID-based automated library system under his able leadership. We are grateful to you, sir. We are fortunate enough today to have three renowned international personalities in the domain of LIS. Professor Carlo Bianchini from University of Pavia, Italy. Mr. Demian Katz, Director Library Technology, Villanova University, US. And our very own Professor K.S. Raghavan, retired Professor DRTC, ISI Bangalore, and Member Secretary SRELS, Sarada Ranganathan Endowment for Library Science. We welcome you all, sirs, and grateful to you all for your kind consent to deliver a talk on the National Librarians Day 2022. May I now request our Honorable Vice Chancellor, Sir, Professor Manoj Kumar Sannal, to inaugurate the webinar through his speech. Sir, over to you.
Thank you, Professor Mukhopadhyay. Good morning to all of you. Am I audible?
Yes, sir. Loud and clear. Loud and clear.
Good morning to all of you. Today is National Librarian Day. Professor Carlo Bianchini, faculty member in Library and Information Science of the University of Pavia, Italy. Mr. Demian Katz, Villanova University, US. Professor K.S. Raghavan, retired professor, ISI Bangalore. Professor Partha Mukhopadhyay, head Department of Library and Information Science of our university. Dr. Deepa Rai, in charge, Central Library of our university. All faculty members, my dear students, research scholars, all staffs of Library and Information Science and Central Library, distinguished delegates, ladies and gentlemen. I am happy to join in the online inaugural session of the international webinar on the theme Ranganathan and Retrieval, organized jointly by Central Library and Department of Library and Information Science of our university. I convey my greetings to all who have joined this online international conference. We celebrate the National Librarians Day on 12th August in memory of the birth of Dr. S.R. Ranganathan, the father of library and information science in India. We know libraries plays a vital role in the development of our society and country, of course. S.R. Ranganathan was the first person who identified the real need of libraries and library science education in our country. Ranganathan had only one goal in mind: to improve libraries and to extend library service to the public. In the pursuit of his goal, Ranganathan had an impact on Indian libraries and gained the respect of librarians around the world. It has been said that Ranganathan gave a purpose, direction, and vision to the profession of library science in India. In today's society, libraries have a greater responsibility to organize the library not only as a store of books, but as a knowledge center. Today, libraries use current trend in all activities, including selection, sorting, and dissemination of information. Everyone is looking out for easy access of information and services from libraries. We are in the process of transforming our central library from a traditional library to a digital library with the help of all library professionals and teachers of our library science and department. We know library staff handle a tedious tasks involving sorting, lending, returning, tagging, monitoring of books. In addition to this, users also find some problems in finding, borrowing, renewing, queuing, etc. To overcome these problems, we will introduce shortly a smart library management system based on radio frequency identification or RFID technology. Using low-cost passive tags in libraries, we are integrating RFID technology management system and makes both the library's users and staff tasks easy, smart, convenient, and practical. As Dr. S.R. Ranganathan mentioned, libraries are growing organizations. We are trying to adopt latest technology to provide better and efficient service to all the students, researchers, and faculties. I do hope this international conference will definitely create an atmosphere of free exchange of ideas, develop new research areas among the researchers. Finally, I wish to thank Head of the Department of Library and Information Science, in-charge Central Librarian, in-charge Librarian Central Library, all research scholars and students, and all the library staffs for the effort and time and dedication for successful organization this international conference. I wish this international conference a grand success. Thank you all.
Thank you, sir, for your valuable speech, thought-provoking speech, and your kind inspiration, because you actually triggered us to organize a series of events in the international arena. And our good friends in different universities of foreign countries readily consented, and we are really, really grateful to you for this idea. So thank you, sir. We are now moving to the next part of the process. Professor Carlo Bianchini is with us. And Professor Carlo Bianchini, it is customary to introduce you all that we are fortunate enough today having Professor Carlo Bianchini from Italy. Professor Carlo Bianchini is currently Associated Professor in LIS at the Department of Musicology and Cultural Heritage of the University of Pavia. He is a noted researcher of different aspects of knowledge organization, including the facet approach of Ranganathan. He has nearly 100 contributions in national and international journals. He is frequently an invited speaker at different professional conferences all over the world. He is presently serving on the editorial board of JLIS.IT, which is a very prestigious journal in our domain, and AIB Study, and served in the editorial board of Bibliotheca Rivasta di Studi Bibliografici from 2003 to 2007. Professor Bianchini, a former member of the Cataloging Commission of the Italian Library Association during 2005 to 2011, is presently an active member of the Italian chapter of ISCO, and ISCO everybody knows in India, and also founding member of SISBB. After earning his bachelor in LIS and PhD degree in LIS from University of Udine, Italy, he worked as librarian at Accademia dei Concordi, Rovigo, during 91 to 1998, and at Museo Friulano di Storia Naturali, Udine again from 2000 to 2010, where under his management, Ranganathan's colon classification was used to organize library collection. His current main research interest area deals with knowledge organization and faceted classification, cataloging, linked open data, and Wikidata, along with information literacy and user studies. So Professor Carlo Bianchini has a spectacular biography and a very well-known personality in the domain of LIS research. Actually, I contacted him through one of his great paper on CCLitBox, and little bit of work we have done at our end also on the basis of the theory he proposed along with his colleague Stefano. So Professor Carlo Bianchini, may I now request to start your presentation and discussion? Thank you.
Thank you. I share my screen. I hope you can see it.
Yeah, it's visible, sir. It's visible.
Okay. First of all, I wish to warmly thank Professor Parthasarathi Mukhopadhyay for inviting me today and all the organizers and all the honorable hosts of this great day for every librarian in the world. I'm going to present to you the CCLitBox, a Wikidata gadget that guides its users to create column classification class numbers for authors and works of the world literature. This is the summary of this presentation. I will show a few previous studies about column classification and its aptitude towards the present bibliographic universe. Then I will remember how the column classification authors and works class numbers are created. I will also give a brief reference to Wikidata as a linked open data dataset. Then I will show how the gadget works. And lastly, I will add some observation about it. In the first three yearly works, the relevance of column classification for the organization of bibliographic objects is underlined. In particular, it is highlighted in relation to column classification accordance with the logical model of FRBR, functional requirement for bibliographic records, its fundamental entities like work, expression, manifestation, and item, but also with the related works, for example, commentaries and translation. The inclusion of related works is a very interesting feature provided for in column classification by Ranganathan due to the relevant presence of the phenomenon of families of works in the Indian literature. The last three works are the result of a research on the feasibility of an automatic process for the creation of column classification class numbers for literature. The process requires the extraction of the needed data from some linked open data sources, its transformation into notation for the individual facets, and finally, the complete synthesis of the notation for the author and the work class number. The process was applied to about 30 Italian authors and their about 100 works. In the dissertation, the same process was tested for the book numbers too, that is to say for manifestation and items according to the IFLA-LRM model. To sum up the previous results, the results of previous studies, we can assess that column classification is able to organize documents based on FRBR entities such as works, expression, manifestation, and items. Moreover, as described by Ranganathan, documents are organized in a bell curve, reflecting that the most relevant documents are in the middle and less relevant ones are disposed on the sides. Secondly, an algorithm to produce column classification literature class numbers from freely available linked open data datasets is feasible. I'm sure that the larger part of you know the column classification much better than me, but it could be useful to remind the basics of classification of literature. The facet formula of main class O literature is the following: O, P, comma, P2, P3, comma, P4, where facet P represents the language of the work, facet P2 corresponds to the literary form, facet P3 stands for the author, represented by means of the birth year, and facet P4 corresponds to the work facet, by which works are usually represented in a chronological order when possible. On the whole, facet formula means that in main class literature, concepts and punctuation must respect the following order: O plus language plus comma plus literary form plus author plus comma plus work number. Every facet is to be used when it applies, as we know. Main class literature is probably a unicum in column classification, as its schedules for classification consist in a list of less than 10 isolates, that is to say, voices. It is also interesting because 2 out of 4 facets, language and time, can be obtained from common isolate schedules. Let's see an example. I choose a drama by Shakespeare because I hope it is well known. First, we have literature O, and English 111, and drama. In the facet P3, the author of the literary work that is contained by or that is a subject of the book is represented by the birth year. Years are determined by means of the time isolate schedule, where each century is represented by a capital letter. For instance, J letter represents all the years from 1500 to 1599. Each single year of any century can be obtained by adding its 2 last figures to the letter representing its century, so that 1564 is J64, and so on. The last part is the work number facet. Today, for ease, we are going to assume that Romeo and Juliet is the first work ever written by Shakespeare. So its work number is 1. Putting all these figures together with the help of the facet formula, we obtain the requested class number. If Hamlet were the second work by Shakespeare, we would obtain the following class number, and so on. Note that we must use the date of the work to chronologically order the works by a given author. For example, Romeo and Juliet 1599, Hamlet 1604, and so on. So the date of a work is a relevant data in the process. Let's turn to WikiData now, very briefly. WikiData is a freely available hosted platform that anyone, including libraries, can use to create, publish, and use linked open data. WikiData acts as the central storage for the structured data of its Wikimedia sister projects, including Wikipedia, Wikivoyage, Wiktionary, Wikisource, and others. It is free, it is open, programmable, modular, and cooperative. WikiData is made of items, a set of data about entities such as persons and works, but also places, animals, plants, colors, personal qualities, abstract concepts, and so on. Let's see an example. I choose Premchand, and how an item is structured. Here we see the item of Prenchant. We have four main sections. The first one is the header. The header is made by, the most important thing of the header is the identifier. The name of Prenchant in Wikidata is Q174152. It is not Prenchant. Prenchant is a label that I can show, for instance, in English or in Bangla or in Hindi and so on. So the string of characters, Prenchant, is just a label. We have also a description, and we can give a description in many languages. You can see here also Italian one. And we have also known as in the header, other names by which an entity is known. The second part is statements. What are statements? Are sentences about the item. So the first sentence is that Q, the Q we are seeing, is an instance of a human. So I understand, as a human, I understand that we are talking about a person, but we have very many statements about a person. The third part is that of identifiers. Identifiers are the other names of the item, Prenchant in this case, within the semantic web. And all the dataset that take part to the semantic web. For example, here we see BIAF or ISNI or Library of Congress Authority ID and so on, Bibliothèque Nationale de France. The last part is that we see here on the right, and it is the links within Wikipedia and Wikimedia project. So many voices about Prenchant in Wikipedia, but also wiki quote, quotation by Prenchant, and wiki source, and so on. And of course, it is different from item to item. Let us return to our presentation. This is a saved slide. If the connection is not so good, I have it ready. But I want to show here and in the following slide that there are very important data of this item. First of all, we have the date of birth of Prenchant, and this is a relevant data for column classification. Then we have Is there an issue? Can I go on?
Yes, sir. Please go on. Please go on.
Okay. There are 3 languages and occupation associated with Prenchant. So why use Wikidata for a project about column classification? Because any data needed for column classification, author, and work class number are either available or can be added in a Wikidata item. What data are available in Wikidata? All the data needed to build the class number according to the first formula, that is to say language, and it is the main language associated with the author, the literary form, that one that is mostly associated with the author. So if we take into account a writer who was, for instance, both a poet and a novelist, we must consider her mostly associated form, or poet or novelist. Author, years of birth, and moreover, some data are available also for the work. I didn't show you a work item, but we know that we have the title and the date of creation or publication of the work within the item of work. In fact, the title is needed to identify and to number sequentially the works by an author, while the date is useful but not strictly essential to order works chronologically. Additionally, all the data elements must be available in a modular, shareable, and reusable form as in Wikidata is. The CCLitBox is a JavaScript program designed in collaboration with Stefano Bargioni, but entirely written by him. Stefano Bargioni was the deus ex machina of the research. What is a gadget? User experience in Wikidata can be improved by means of preferences and gadgets. Gadgets are programs made up of JavaScript snippets and are located in the MediaWiki namespace, and they are preferences in this case, or in the user namespace, that is the user.common.js file. Gadgets can perform a large variety of tasks, such as adding data, moving data within the page, sorting list of values, adding data from other Wikidata items or external resources, linking external resources, and precompiling the object values of Wikidata properties, also called statements or triples, as we have seen just before. The CCLitBox gadget was created for the analysis, synthesis, and production of column classification author and work class numbers within Wikidata. This slide shows an item of an author in Wikidata. In this case, the author is Srishendo Mukhopadhyay. As far as I am a Wikimedia registered user, and I included the CCLitBox in my common.js file, the gadget is loaded in the item page by my browser. To be honest, sometimes it doesn't work and the page must be reloaded. Be careful. The gadget searches for and identifies the data required by the first formula within the author item. Then it collects the data and shows them on the left. Lastly, on the right, the gadget suggests the calculated class number for the author that will become the column classification identifier for that author within Wikidata. So we are not just classifying, but we are giving an identifier to the author. This will be relevant in the discussion, in the final discussion. Two buttons are available to interact with the gadget. The save button to accept the value and to record within the item the author, or the reset button that allows the browser to reload the page. As we will see in a moment, in the second part of the box, the CCLitBox in green, the gadget identifies any works linked to the author whose data are present in Wikidata, extracts the data and calculates the corresponding column classification work class number. For every work, a black button enables the creation of the relative class numbers within the Wikidata item of each different work. Moreover, the CCLitBox is interactive and enables the user to choose the more correct value to be used in the creation of the author class number. In this case, Wikidata records that Mukhopadhyay was both a writer and a novelist. In the gadget, chooses the first relevant value. In this case, the value is writer. In fact, we can see that the suggested author class number contains the figure 6 after the first comma. That means writer, and we read it on the left. But it seemed more correct to identify Mukhopadhyay as a novelist. So what can we do? We can interact with the gadget and open the drop-down menu. So the gadget will show all the possible values recorded in Wikidata author item in the property occupation. Here you can see the drop-down menu. This menu is available every time that in Wikidata more than one value is recorded both for occupation and language. If we choose novelist, the column classification author class number will be updated consequently. Under the arrow, the proposed value for column classification author class number has changed to contain figure 3, that is to say, novelist. I wish to underline another feature of the WikiData gadget. You have noted that up to now, we have seen all the data and metadata presented in English. But thanks to the WikiData platform, to obtain a more user-friendly language is only a matter of setting user preferences. In fact, by setting the preferences to Bengali, you see the metadata and the buttons in Bengali. Metadata are translated by WikiData, while the buttons must instead be translated within the gadget, which is possible because it is open source and therefore allows anyone to make the appropriate changes. Let's see a live demonstration, hoping the internet connection is stable and everything goes well. Here we have the English page for Shishendo Mukhopadhyay, and I will try to translate it in Bengali. Here we have, to go on, unfortunately, I must return to English. The CCLit gadget is loaded by the browser, so it needs some time. Now I can interact with the left part of the box, and I can choose novelist. The proposed class number is updated, it is 3, and now I can save it. I can go down in this item and I can see that column classification is, was added to the identifiers of this item. Let's give a look. If you find it, column classification, just add it. Okay. Let's return to our presentation. Some consistency checks are performed by the gadget present, and the checks are needed because the column classification property should work as an identifier and it cannot be duplicated. What kind of consistency checks are we performing now? Author might already have the property for column classification, that is the number for the property of column classification within WikiData. So we get we get a warning message. In a moment, we will see some slides that show all these consistency checks. More than one author of the same kind, for example, 2 poets or 2 novelists might be born in the same year, because we are talking about identifiers. They must be disambiguated. Works might already have the property for column classification and they appear in green without button, and works might miss some properties needed to create a column classification number, and they will show in red. This is the warning message for an author that already have the property for column classification recorded. So I don't, there is no need to click on save button. This slide shows that there are warning message related to author of the same type born in the same year of the poet Maria Luisa Spaziani. Column classification numbers must be disambiguated by means of the alphabetical device as provided for by column classification rules. In these cases, the first letter of the family name was added to the second and the third class numbers, and the letter S will be added for the poet Maria Luisa Spaziani. The second part of the box is devoted to the works of an author. Here we see, thanks to the message at the beginning of the second part of the box, that the English novelist David Lodge has already the property for column classification, so we can go to examine his works. We see that the first two works already have column classification numbers in green. No action is required by the user, in this case. A second group of works do not have column classification number, and they can be created. A black button to create column classification work class numbers for each work is available and it can be clicked on. And finally, the last work exists in Wikidata, but it misses some data necessary to create its column classification number. So it is displayed in red and no button is available to avoid mistakes. Let us consider some issues that Wikidata creates to the CCLitBox. Author missing required properties and related works or work items poorly described in Wikidata are very frequent. Sometimes only a few works have a full and correct data. Nevertheless, in order to preserve a chronological organization of the works, the whole literary production of an author should be recorded and described in Wikidata before proceeding to the creation of the column classification work class numbers. Anyway, as seen before, missing data in Wikidata prevents CCLitBox from creating property for column classification for both authors and works. In these cases, firstly, the user must open the Wikidata item of the author or of the work and complete data in the item. Only after that, he can come back to the author item page, reload it. Please note that Wikidata requires a lag time that can be up to a few minutes after an edit, and create the column classification numbers for the author and the works by means of the now black buttons. Another possible issue is that of missing languages. A language can be absent in the gadget or in the column classification schedules. Here are two examples: Basque, a language spoken in Spain, and of a regional language in northern Italy. About languages, I am very glad to say that a major work for the 22 constitutionally recognized languages of India was done by Professor Mukhopadhyay to include them in the CCLitBox. Thanks from the core of our hearts for this great job to Professor Mukhopadhyay. Main advantages of the CCLitBox are: it is a totally free tool that enables any user to classify literary authors and their works by column classification, even without knowing well the column classification. The tool is easy, accessible to everybody, just an internet connection is needed. It can be used to produce and create class number and to classify a library collection in literature virtually from all the world. The tool is available through Wikidata that empowers the user to add missing data when needed, and so to complete the column classification. Because the tool is based on the Wikidata environment, it is ready-made for any cooperative and networked effort. As to the last point, in fact, it was very easy to cooperate among us and Professor Mukhopadhyay, enhancing the feature of the column classification LitBox by solving issues emerged during the application of the gadget in India. We must consider some limits of this gadget. In fact, it works, but it needs more improvements for new languages and to improve consistency. A major improvement would be to pull it out from Wikidata and enable it to reuse data from more sources than just Wikidata, such as linked open data set from the most important national libraries in the world. We must consider also column classification limits. Column classification facet format is not designed as a full identifier device for authors and works. For example, poems and novels by the same author result spread in different class number following strictly column classification. It means that column classification assigns a different class number to an author when she writes poems, dramas, and novels. This approach is more user-friendly, but prevents from the identification of an author that is a basic requirement of the semantic web, not just Wikidata. Column classification language schedules are mainly devoted to Indo-European, Semitic, and Dravidic languages, currently 54 ready-made class numbers, so that other languages need much longer notations to be represented. A possible solution could be to replace column classification notation with the ISO language code table, which is based on a number of 3 figures, just like the figures provided at the moment by column classification. To sum up, as you can see, the column classification would need to be subjected to the application of the 5th law of library science. Thank you all for your attention.
Thanks for an illuminating speech, Professor Bianchini. Really, very lucid, and the way actually our students and scholars too, very, they are interested to develop something on the basis of this theory, maybe extending this scheme to another schedule, like structured schedule, like agriculture or medicine. So let us hope I will be keep you posting that what we are doing at this end on the basis of your work, and Stephanie Balguin, of course, he is the main engine behind this particular step. Okay, so thank you very much. And with your kind permission, we are now moving to the next part of this, process. So our next, speaker will be Mr. Demian Katz, and Demian Katz is what not actually. Demian, I occasionally call him by the first name because we are working very closely in the VuFind community. So Demian Katz is a community manager of the VuFind community, the famous open source library discovery system. He is presently working as the director of library technology at Falvey Memorial Library, Villanova University, and of course, a leader in the VuFind code base. And he is a rare combination of dual degree professional, a programmer, analyst with a library science background. He is experienced in development and maintenance of large-scale, complex web-based application and in management of different open source projects. So despite of his busy schedule as a global scale expert in solar search technology, digital repositories, of course, VuFind discovery system, then different kind of image management program, semantic web technology. He is also actively involved in scholarship related to dime novels, story papers, and other early forms of printed popular culture, in addition to being a bibliographer of print-based interactive fiction. In short, Demian is a VuFind developer, a librarian, a dime novel enthusiast, a game book expert, a guppy breeder, Whovian, and crazed bibliographer. I don't know. For him, it is also 24 hours a day or not, I simply do not know. But he is managing and maintaining all of these activities with equal space. So unfortunately, as you know, that this is in US almost at 3:30 a.m. So Demian Katz cannot be present here in person, And he sent us beautifully structured video lecture, and that I am going to play for all of you. So please wait a bit so that I can share it. Okay, so let me share it.
Hello and happy Librarians Day. I am Demian Katz, the Director of Library Technology at Falvey Memorial Library at Villanova University. Thank you for inviting me to speak today, and I'm very sorry I can't be here live or in person, but I hope that these pre-recorded remarks will be of some interest. I'm here today to talk about trends in retrieval, discovery versus search. So to give an overview of what I'm going to talk about today, first of all, I'll just say a few words about VuFind, the open source project that I work on, because I'll be using it in some examples throughout the discussion. I'll talk about my thoughts on the differences between discovery and search. I'll discuss some search trends and how libraries and librarians might fit in with them. And finally, I'll talk about a project I worked on to rediscover serendipity in the digital age. This is a topic I've talked about in the past, so I hope I'm not repeating myself, but it's also an area where I think there's more potential for research and improvement, so I hope that sharing this information again will be of interest. So first of all, a few words about VuFind. It is an open source search and discovery layer. You can use it for free. It provides a common interface, a user-friendly interface too, to various search tools and services. So for example, you can create an index of your local catalog records. You can connect through APIs to third-party services like EBSCO Discovery or WorldCat, and you can present all of this in a uniform and customizable way to make your end users access to materials more user-friendly and convenient. It also connects with a wide variety of integrated library systems, including open source ones like Folio and Koha, as well as many of the major commercial players like Alma, which allows your patron-facing functionality to be integrated with it. So users can place holds on books, renew books, check their finds, and so forth. So having gotten those specifics out of the way, let's back up to a more general discussion. So the subject today is discovery versus search. And those are both words that could have a lot of different meanings. So let me share my thoughts on what they mean, which will influence my remarks today. So first of all, discovery. When I hear discovery, even though the word is often used sort of interchangeably with search, my thought is that this is about serendipity, about finding that which you did not know you needed. If you already know something is there, you can't really discover it. You've just searched for it. But in an ideal library environment, whether in person or online, there are many possible opportunities for people to discover amazing things. Search, on the other hand, is about finding something specific. You know that it exists, you just need to get to it. I also view search as being about finding a comprehensive view of the subject, trying to recall as much information as possible. And so these two things really complement one another, and I'll talk about that a little later. So first of all, some general thoughts on searching, and I may be showing my age in some of these remarks, so I apologize if I just sound cranky, but it all is to a purpose. So first of all, I think from a librarian's perspective, the key thing is that search should be empowering for users. If we offer search services, we want those to help our users find the things they want. That is our primary goal. So with that in mind, my question is, has search really improved in the past 20 years? And when I say search, I'm referring in large part to commercial search engines. And specifically, a trend that I find somewhat concerning and which I will describe as algorithmic relevance over depth. So 20 years ago, when search engines were new, they behaved in a very predictable way. You put in some words, you got a list of documents matching those words, ordered based on some relevance algorithm. But pretty much the rule was, if you add more words, you narrow down your search. If you enter fewer words, you broaden your search. And you usually had very deep pagination so that you could work your way through a large set of results if you wanted to. However, over time, a lot of usability studies have shown that nobody goes past the first page or two of search results, generally speaking. And so a lot of work has gone into making sure that those initial results are as good as they can possibly be. And often this works well, and we do find the things we want when we perform searches. But I also feel that in some ways this is disempowering for users, because sure, it's great when you get what you want, but if you don't get what you want, you have fewer ways of finding more. And when you perform a search, the results you get back are often less predictable than they used to be, with the algorithms randomly ignoring certain words, factoring in geography, or adding bias in perhaps undesirable ways. And just as a quick example of this, I did a search and the results actually surprised me, even though they somewhat met my expectations. So one of my other fields is working in dime novels, and I just did a search for a dime novel that I find interesting called The Bride of the Tomb by Mrs. Alex McVeigh Miller. So I just went to a couple of search engines and typed in the search Bride of the Tomb as a phrase and Miller, the author's name, just because I wanted to see what kind of results would come back. So in Google, I was told that it found 291,000 results, but when I actually tried to page through the result set, it stopped after 79, telling me that many of the results were redundant. And even those 79 results that I did get were largely redundant, with a lot of useless links, obvious spam sites, and so forth. I tried Bing and got an even more absurd result. It reported 2,120,000,000 results, and then only let me access 44 of them. It gave me a paginated result list showing 5 pages of results, but it wouldn't let me go past page 3. So what is going on here? I can't honestly tell you, but this is the sort of thing I've been encountering more and more recently. And as I say, I find it concerning. Certainly, many users, according to sort of the 80-20 rule, many users are happy with this, find something good on the first page and stop. But this seems to me like a threat to really in-depth research and comprehensive analysis. And I'm not happy about that. So my question is, can libraries do better than this? And to answer my own question, what can libraries do? And I think there are a few things that libraries should really consider doing if they're not doing them already. One is grow in-house expertise. I've talked about this before, but I still feel strongly librarians have a skill set that's very complementary with technology skills and have the professional mission to do things in my opinion, a better way than many of the commercial technology companies can do. So I think libraries should really encourage staff to learn about technology and apply what they learn. And open source projects like VuFind offer an opportunity for that. I think that we should collaborate at scale. It's often easy to look at something like a major search engine and say, we can't possibly compete with that, it's too big. But through collaboration, perhaps we can achieve more than we think. And again, projects like VuFind, which are extremely collaborative and involve dozens or even hundreds of libraries, have proven that if we put our resources together, we can achieve big things. Of course, I also don't suggest that we can just do away with commercial services. We always are going to need to collaborate with the private sector in some ways. But I think when we do make these collaborations, we need to be sure that we hold those vendors to high standards of transparency and portability and good user experience. Even if we can't build things, we certainly understand how our users interact with systems and what our users need. And we should communicate and advocate for these things. Finally, we should continue to educate our users to think critically and search carefully, because a well-informed user is better able to engage with search and perhaps advocate for improvements in the future. So, stepping back from my my high horse, let's talk about not just the differences between search and discovery, but the way that search and discovery can integrate with one another. So specifically, I'm talking about the fact that while search and discovery may be distinct, there are also opportunities for discovery within search. One example of this is in VuFind, we have a mechanism called recommendation modules, which are a set of plugins that can be configured to display additional information informed by search results. These can take the form of things like the classic faceted search, where certain aspects of the search result set are highlighted and then the user can narrow down. I view this as a form of discovery because it shows sort of shared characteristics of a result set in a way that would be hard to recognize just looking at the results one at a time. We also have the ability to incorporate authority data, which I think has a lot of potential for future discovery. As more and more sites come up with unique identifiers for things through linked data and other methods, there's the opportunity to look at a search result, figure out what it's about based on its content, and then locate other things with similar subjects, authors, etc. And again, VuFind has the ability to do some of these things like showing cross-references that are relevant to a result set and so forth. Another sort of hybrid between search and discovery is the so-called bento box search, which is a system where you enter search terms into a single box, and then you get back multiple result sets from different sources. And VuFind supports configuring this. Many other systems use it as well. It's a useful mechanism where if you have very divergent types of information and you're not sure which one your user might be interested with, you can surface results from all of those places, and then your user can discover what things are available and choose where to navigate from there. So having talked about integrating search with discovery, what about pure discovery? I think this is something that is often shortchanged in the digital environment because we're so focused still on search. So let's talk about the problems with serendipity in the digital environment. Historically, a lot of scholars have put a high value on browsing the shelves of a library. You can find a book that you want and then see things nearby that are exciting, and this can lead to all kinds of discovery. This is sort of the classic traditional library discovery model. But more and more of library resources aren't on the shelf at all. We have so much purely digital content, and even for books that are available in print, more and more libraries are choosing to purchase ebooks instead, both from user demand and considerations like space, because as the library reduces the emphasis on collecting, we're also increasing the emphasis on human interaction and collaboration, and our library buildings are in many cases using space in different ways. So there are fewer shelves to browse, or those shelves are compact shelving, which is less friendly to the user, or we have automated storage systems. In all of these cases, the traditional shelf browsing becomes increasingly impractical. So what can we do about this? One solution that I've seen people take is to just build a digital shelf. And while this is kind of fun, I've never really liked this solution because I don't think it's particularly effective or meaningful. A real shelf in the real world is part of a three-dimensional environment. We can move up and down and look behind us. Our books are all different shapes and colors. And while this example I have a picture of here does make some effort to differentiate the books using, the height measurements from the records and the page counts, it's still just a monochromatic linear display, and scrolling through titles that have their pictures that are on pictures of book spines is not the same as they're just not doing it in the library. They're doing it in places like entertainment platforms like Netflix, which have developed these very browsable interfaces that tend to be focused on identifying categories of things and then creating very visual representations of the items in those categories. And taking inspiration from this trend, a few years ago, I added a new feature to VuFind called channels. And you can see an image of the channels interface as implemented at Villanova here. And I apologize for some of the ugly, tiny thumbnails you'll see in my screenshots. These were taken before everything was polished, but they should serve to demonstrate how everything works. So what are VuFind channels? Essentially, this is a mechanism that can take a few different inputs and provide channels as an output. So specifically, there are 3 places where you can start in VuFind channels. You can start with any record in the system. So, you know, if I like book X, I can say, give me channels that are in some way related to this book. Or you can start with a set of search results. I can put in a search term and get channels that in some way represent the result set. Or I could just say, I want to discover something. There's a general starting point that will bring back some initial channels that can get somebody started in exploring a collection. All of these channel setups are fully configurable in VuFind, so you can decide in each of these 3 contexts what types of results are displayed and where the information is drawn from. And so in each case, based on your configuration, VuFind generates a list of channels, and each channel has a title explaining what its theme is, and it contains a list of records related to that channel. It often has controls that will allow you to add additional channels along similar lines. And all of the code that generates the channel is designed in a fully pluggable way. So if you have an idea for a channel that does not already exist in VuFind, you can write a little bit of PHP code to implement it, plug it into the system, and you're ready to go. The interfaces are all pretty straightforward. So let me show just how the navigation of channels can work. So this first example shows that if we click on an item in a channel, we can explore other channels related to that item. So here we're seeing similar books and some related topics. So topics matching the topics of the book we clicked on. And just to repeat the video, there we are. We click on the book. Here are our related channels. Similarly, we can narrow down and explore related channels. Any given channel can be clicked to get a list of more similar channels. And then we have this drop-down menu of additional things to add. So in this case, we're showing channels inspired by subject headings in the search results. And VuFind by default is going to show just a few of the most commonly used subject headings. But this drop-down menu lets users explore other topics if there's something that's more relevant to their research. So having shown those little examples, let's talk about the kinds of channels that are available. The first is what I call static channels. These are channels that will always return the same content regardless of the user's input. And they fall into 2 categories. One is ILS-based channels, which pull information from the integrated library system. So for example, one can bring back a list of new items that were recently added to the collection. So you can have a channel of what have we most recently acquired. Another is trending items. So if your ILS supports it, we can run a query on circulation, figure out which books have circulated the most recently, and then highlight those in the channel. And similarly, we can highlight items that have been recently returned. So presumably someone wanted them for a reason. They're now back in the collection. Maybe it's a good idea to highlight those to our users. Additionally, we can have channels based on user-generated content. Specifically, VuFind has the ability for users to create lists of records and make them public. And there is a channel that can just be linked to a public list and display all the records in that list. And this can be used if you want to intentionally curate a particular channel of records. Then, of course, if we've talked about static channels, there are also dynamic channels. So some are search-based. As I mentioned in the example I showed earlier, we have facet-based channels, which will look at the facets of a search result set and then apply those facets and display channel content based on that. We have random channels available, which will just pick arbitrary random items from a result set. This could be useful for just mixing things up a little bit. We also have a channel for using similarity algorithms, which are usually based on author, subject, call number, similarity, to show records that resemble those that are coming back in the search results. We also have browsing-based channels. So for example, we can do a channel that shows what is near the records in the search result by call number. This is sort of the closest we have to a traditional shelf browse. But of course, we can browse in other dimensions as well. What are nearby titles, nearby authors, nearby subjects? And in addition to the channels that already exist, as I mentioned, VuFind is very extensible. There's a lot of potential for building new channels in the future. So, for example, there are all kinds of different APIs out there that can retrieve interesting data. It wouldn't be too difficult to build channels that leverage them. So, for example, we could talk to external services, like, for example, there are similarity algorithms where you can input a particular book and get recommendations for other books that people like. We could leverage linked data. I mentioned earlier that linked data can be a good way of augmenting search with discovery-like characteristics. We could certainly do that in the channels as well. Also, many of the commercial entertainment platforms like Netflix do usage-based analytics, and libraries tend to be wary about doing this. And I think there are good reasons to value user privacy and be careful. But if you have data that can be used in a responsible way, there is potential for looking at long-term usage trends and borrowing patterns and using that data to make recommendations that could be exposed through a channel. And that is all I have. I thank you for your attention, and I encourage you to learn more about VuFind if this project sounds interesting to you, and to reach out to me if you have any questions, comments, or suggestions. I am always happy to collaborate with people. That's one of the joys of working in open source. So don't hesitate to reach out. As you can see on this slide, you can email me at demian.katz@villanova.edu. I'm on Twitter at Demian Katz. I've also placed my phone number here. And if all of that is not enough, there are a number of other places you can find me, including the VuFind Slack channel and GitHub. And since my name is fairly uncommon, I'm not too hard to find. So thank you again. I hope you have a wonderful Librarians Day and a wonderful conference. And I hope to see you again soon.
Thank you, Demian, for such a thought-provoking lecture. Particularly, we people are involved in the VuFind community, and the usage of VuFind in Indian environment is growing. The channels feature what Demian talked about is actually available from version 8.x, and from version 9.x, which will be due in the next January. We'll be having a beautiful search discovery integration, which is called Blender search. So we are all waiting eagerly to implement version 9 of VuFind with channel configuration and this Blender search. So now let us move to the next part and the last part of our presentation by Professor K.S. Raghavan. Professor K.S. Raghavan, it's introducing Professor K.S. Raghavan to all of you is something like introducing ice to Eskimos or sand to Bedouins. He is so well known to all the allies fraternity in India. He joined this University of Madras as a teacher, taught there for long 22 years, then joined DRTC, the institute founded by the father of library science in India, Dr. S.R. Ranganathan, and worked there for another 8-10 years, and finally retired from there, and now working as a consultant in a nearby institute in DRTC, that is called Knowledge Engineering Organization, KEO. He is an active member of different organizations like ISCOs and this UNESCO group, IFLA committees, and so on. And he is presently working as the chief editor of SRELS journals of information management, a quite popular journal in India, in LIS, and also a member secretary for this SRELS, Sarada Ranganathan Endowment for Library Science. So let us start his talk, and he is not quite available nowadays because he is now staying in US with his daughter. So again, the time gap is there. It's actually late night in his place. So he kindly sent us a video on this particular purpose. So I'm going to run it now.
Outset, I must thank my good friend, Professor Parthasarathi Mukhyopadhyaya, for inviting me to this very important webinar to give a talk. He titled my talk as Rediscovering Ranganathan. It's important and good that the webinar is looking at the relevance of Dr. Ranganathan in the context of present-day information retrieval requirements. There have been, in the recent past, several questions about the continued relevance of Dr. Ranganathan's ideas. Now, this is particularly pronounced in this present digital age. In fact, a couple of years ago, to celebrate the 125th birth anniversary of Dr. Ranganathan in 2017, the Sharada Ranganathan Endowment for Library Science, ISCO Singapore chapter, ISCO India chapter, and the Indian Institute of Technology Madras had organized an international conference on relevance of Ranganathan, reinventing Ranganathan. That was held in 2017 at the Indian Institute of Technology, Madras. A few years ago, the OCLC, the Online Computer Library Center, looked at Dr. Ranganathan's 5 laws of library science and examined if there is a need to reorder these 5 laws of library science in terms of their importance in the present day context. In fact, they came out with the idea that the 4th law of library science, save the time of the reader, should now be the very first law of library science. So it's not that we are looking at this particular question of how relevant Dr. Ranganathan's ideas are in the present day context. There have been attempts even earlier looking at this particular issue. There is hardly any facet of library and information science that Dr. Ranganathan has not touched upon or has contributed to. Look at some of his most significant contributions to this discipline. domain of library and information science and information service. His 5 laws of library science have provided the theoretical basis for all library and information work, library and information science, and information service. Ranganathan was of the view that normative principles should govern the practice of any library work, library service. Looked at from a slightly different angle, the 5 laws of library science also suggest that Dr. Ranganathan adopted the systems approach. In fact, years before, Ludwig van Bertalanffy came out with his systems approach. In effect, the 5 laws of library science are a clear statement of the objectives of library and information work and service. Ranganathan has also contributed to public libraries and library legislation significantly. His contribution to university and academic libraries is well known. He was chairperson of the UGC Review Committee on University and College Libraries. His contribution to special libraries and documentation, reference work and service is also very well known. His masterpiece, the new media and school libraries, is still a classic insofar as school libraries are concerned. His input to education for library and information science stand out. He was the first to introduce a postgraduate diploma in library and library science in the University of Madras, the first to be introduced in this particular country. He worked on library education at the BHU, the University of Delhi, which was the first university to start master's degree program in library science in India, and later when he established documentation, research and training center as a component of the Indian Statistical Institute, he focused on requirements of industrial and research libraries, especially in terms of documentation. He was also the chairman of the UGC Review Committee, which produced a report which served as the basis for design of library science programs in Indian universities. Till recently, Dr. Ranganathan was generous enough to contribute his entire life savings to the University of Madras to create the Sharada Ranganathan Chair in Library Science, probably the first chair in library science in the British Commonwealth, University Chair in Library Science in the British Commonwealth. His contribution to setting up national information infrastructure in the form of National Plan, Library Development Plan, his contribution to setting up of INSTOP are only too well known. Dr. Ranganathan also did significantly contribute to the library profession as such. He was the founder of several library associations, including the Madras Library Association, the Karnataka Library Association, which was then known as the Mysore Library Association, the Indian Association of Teachers of Library and Information Science, IATLIS. Ranganathan's work for international bodies such as UNESCO, IFLA, FID, etc. is also only too well known. However, when we are looking at relevance of Dr. Ranganathan's contributions, what stands out is his work contributions to knowledge organization, the field of classification, indexing, and cataloging. And it is for his work in this particular area that Dr. Ranganathan is well known and recognized globally. The theme of this particular webinar, Ranganathan and Retrieval. And therefore, what I plan to do in this particular presentation is to largely restrict my talk to this particular area and will only briefly touch upon some closely related aspects that are related to the issue of retrieval. Perhaps the most comprehensive definition, at least the one that I have come across, of information retrieval is the one that has been provided by Dr. G. Bhattacharya. He defined the term information retrieval as retrieval of information about documents containing required information. Second, retrieval of information about location of required information. Third, retrieval of information qua information. The first one, if we look at that particular definition, is the sense in which Calvin Muyers, you will recall that it was Calvin Muyers who coined the term information retrieval. So the first definition of Bhattacharya reflects the sense in which Calvin Muyers used this particular term information retrieval and defined it. This is the result of searching a bibliographic database, a library catalog, an abstracting, indexing service, so on and so forth, where we retrieve documents relevant to a query. The second definition of Bhattacharya refers to the process that takes place when one searches, for example, the back of a book index. When you search the back of a book index, it refers to a section or a page number where you find information on that particular topic. The third definition of Bhattacharya refers to something very similar to a question and answer system kind of situation, where the system responds actually with the information itself, that is the actual information. For example, such queries as what is the height of Mount Everest? What is the population of Calcutta? When did man first land on moon? Now, these are questions for which you can give an answer in a question and answering system. What is the height of Mount Everest in terms of so many meters or feet, whatever it might be. Now, if we look at these definitions of information retrieval vis-a-vis Ranganathan's predominant area, knowledge organization. Now, information retrieval is about building systems, designing systems that assist finding relevant information or sources of information. Knowledge organization per se is a sub-discipline of library and information science concerned with representing information objects to support browsing and information retrieval. Knowledge organization is concerned with indexing, classification to support retrieval, browsing, and many other related processes. It could be a manual system such as a printed catalog, a card catalog, or a printed abstracting and indexing service, or it could be a machine-held database. It could be manual or by machine. So basically, knowledge organization is one branch of library and information science that includes document description, indexing, and classification performed in libraries, databases, archives, etc. So if we look at information retrieval, it's evident that some form or level of knowledge organization is a necessary prerequisite for efficient and effective information retrieval. Now we look at Ranganathan's contributions to knowledge organization, and towards the end of my presentation, I will look at the relevance of Ranganathan, continued relevance of Ranganathan. Of course, the discipline of knowledge organization has its roots in philosophy. However, for philosophers, it was primarily an intellectual exercise, an exercise in mapping branches of knowledge. However, when we try to use knowledge organization systems or design systems of knowledge organization for libraries, we are looking at knowledge organization systems that should deal with physical objects, documents of all kinds, necessitating a scheme for linear arrangement of documents on library shelves or bibliographic records in a surrogate file, such as a library catalog. Any examination of Ranganathan's ideas and their relevance to present-day information retrieval requirements, we will come to this idea of what actually are the information retrieval requirements in the present day. So we must look at two related but different aspects. The first relates to Ranganathan's colon classification. We must remember that Ranganathan's colon classification was designed essentially as a scheme of library classification. He experimented its application for classification and arrangement of books on library shelves, particularly in the Madras University Library and later in many other libraries. We also must remember that all of Ranganathan's work was prior to the advent of the digital era. All his work in classification was carried out before the digital age. And the scheme was designed in the first quarter of 20th century, when printed books and periodicals constituted the major resources of libraries. Logical, linear arrangement of documents on library shelves was one of the primary requirements to support browsing and recall of documents from shelves. And of course, Ranganathan was a staunch advocate of a classified file, just as Dewey himself was. So building a classified catalog supplemented by an alphabetical index to facilitate search and retrieval of documents. Clearly, Ranganathan was aware of requirements of linear shelf arrangement vis-a-vis that of information retrieval. There is no question about this. He was aware of it. He was aware of the limitations that a linear shelf arrangement would impose on a classification system or a system of knowledge organization. So to complement shelf classification, shelf arrangement, and arrangement of records in a classified catalog, to a certain extent, Ranganathan came out with the idea of chain indexing procedure. Of course, the idea had its roots in Dewey's relative index, and Ranganathan was influenced by Dewey's relative index, but it was Ranganathan who systematized chain indexing. He was the one who gave the name chain indexing to this particular process. Look at chain indexing. A chain index, what does it do? A chain index, when you apply it to any classification scheme, merely inverts the classificatory hierarchy and thus significantly enhances search and retrieval capabilities. Jack Mills referred to this particular property of chain index as collocation of distributed relatives. Jack Mills, in his introduction to universal decimal classification, also suggested that chain index is the best way to index any classification scheme. If classification schemes in some form or the other continue to be relevant, even in the digital era, then chain index continues to be a very effective and efficient way of indexing any classification scheme or a classified catalog. I doubt very much if the library information science profession has produced a better and more effective way to index a classified catalog or a classification scheme to this day, although chain indexing was developed more than almost 100 years ago. At this point, it's also relevant for me to mention a paper published in Journal of Documentation by Dr. Ranganathan in the year 1964. This particular paper looked primarily at the relevance of facet analysis, facet analytic approach to building an alphabetical index. It was one of his most significant contributions in the sense that this probably was the first time that Ranganathan looked at the need for a very comprehensive alphabetical index, an alphabetical index to a set of documents to facilitate retrieval. What should I say? Was he moving away from a notational system to an alphabetical system? Well, we can find some indication of this in this particular paper of Dr. Ranganathan, published as early as in 1964 in the British Journal of Documentation. Within a decade of publication of this particular paper, the result was very evident. A series of string indexing systems developed, including PROPSI, the postulate-based permuted subject indexing, developed by Neelameghan and Bhattacharya, and later on Bhattacharya came out with his own theory of subject indexing languages, what he called as the general theory of subject indexing languages. PRESI in UK and many other string indexing systems elsewhere. It's also to the credit of Dr. Ranganathan that he came out with the idea of measuring the performance of an information retrieval system quite early. Of course, Dr. Ranganathan did not quantify this, but his book talks about the requirements of a documentation system, an information retrieval system. It should retrieve exhaustively documents relevant to a particular query, which in essence refers to the recall measure. It should retrieve expeditiously information, documents relevant to a particular query, which refers to response time. And the retrieved documents should be pinpointed, which refers to the precision performance. Of course, as I mentioned, Ranganathan did not quantify this. He didn't give how actually one can compute this to quantify the performance of a particular retrieval system or a catalog. But we must remember that this idea of Ranganathan came up years before Aslip Field studies came out with recall and precision measures. The second major contribution of Dr. Ranganathan to knowledge organization is the technique of facet analysis. The technique of facet analysis has found applications far beyond his colon classification. In fact, facet analysis and the idea of fundamental categories Dr. Ranganathan gave was the basis for much of classification research group's research in the area of classification and indexing, spanning more than 2 decades, the 1950s, 1960s, and 1970s. There is no question that the facet analytical approach to classification is the single most important contribution to the theory and practice of knowledge organization the 20th century witnessed. What do we find when people look at this particular technique today? The idea has proved to be portable across time and technology, and even into the internet era clearly demonstrates its resilience, adaptability, and flexibility. Okay, let us now look at some of these in the context of present-day requirements of information retrieval. What can we define as the objectives of information retrieval systems? To categorize information objects in such a way as to achieve acceptable levels of recall, precision, and response time in response to a search to meet an information need, a defined information need in the form of a query. Second, to facilitate navigation to related concepts like, or related information objects. For example, a thesaurus provides links to narrower terms, broader terms, related terms. A catalog relates to other related works. For example, if we look at a particular record for a book, it may relate to a film that is based on that particular novel, so on and so forth. So navigation between related concepts, related information objects is one of the most important requirements of information retrieval systems today. And a third very important requirement today, presently in the context of information overload, is that a system should be able to rank the retrieved information objects in an order of decreasing relevance to the information need or query. Both manual and machine-based systems, tools, and approaches have been employed today in performing tasks of knowledge organization to support information retrieval. Knowledge organization as in classification, for example, classification of documents, including Ranganathan's scheme, has primarily aimed at reflecting the classification knowledge in the domain knowledge, how specialists in a particular area have looked at that particular domain. For example, books in chemistry, in how they are classified in classification system will largely reflect, for example, the classification of elements in periodic table. The notion of systems and specials, which is evident in Ranganathan's colon classification, for example, mathematics, or physics, philosophy, history, political science, sociology, medicine, etc. Now, all these reflect Ranganathan's, our colon classification and many other classification schemes adopting the approach of looking at a particular domain as the specialists in that particular domain have looked at. Information retrieval, on the other hand, is today dominated by search engines such as Google. Now, these search engines are largely based on matching techniques, measures of popularity, like, ranking depends on the number of incoming links to a particular website, so on and so forth. So the present approaches to information retrieval had their beginnings in the 1950s, mainly pioneered by computer scientists, beginning with, for example, Hans-Peter Lund of IBM. Hans-Peter Lund was the one who coined the term selective dissemination of information. Incidentally, I may mention here that years before H.P. Lund came out with the idea of SDI, Dr. Ranganathan had coined a term known as PARS, P-A-R-S, personalized assistance to research scholars. And it was very similar to, he would maintain profiles of research scholars in the Madras University, not just Madras University, even outside, very important users of the Madras University Library, and provide them documents by matching their profile with incoming documents. He would provide them list of those documents. Very, very similar to selective dissemination of information, which was coined by H.P. Lund much, much later. Now, the work which was initiated by H.P. Lund in the form of keyword indexing, etc., automated indexing, was carried forward by many, including Salton at Cornell University, Spark Jones at Cambridge, etc. And this work today continues both in academic institutions as also in commercial organizations like Microsoft, Google, so on and so forth. Much of this research is reported in text retrieval conferences, or TREC, which are actually a series of conferences that are held annually to report research in this particular area of information retrieval. The TREC has several tracks. Just to give you an example, one of the tracks, clinical trials track, focuses on research on the clinical trials matching problem. Given a free text summary of a patient health record, research in this track seeks to find suitable clinical research trials for that particular patient, what have been there earlier. Deep learning track is another one which focuses on research in document retrieval and passage retrieval. There are several tracks like that. So information retrieval research kind of work that was initiated by H.P. Lund in 1950s and then later by people like Salton, etc., is being continued to this day. Now, what actually are the requirements, present day context? What are they characterized by? The most important characteristic that affects information retrievals today, or requirements of information retrieval systems today, is the information overload, the volume of information, the rate at which information is growing, the environments and context in which information is sought or used, the nature and variety of information, the medium in which information is packaged. I will just briefly look at some of these. Of course, this is a screenshot for writers giving you an idea of the volume of information that is getting generated in just in the form of news stories, nothing else, just news stories, whether it relates to politics, sports, etc. Earlier, if we go back to the Ranganathan era and much of the first 3 quarters of the 20th century, information retrieval was largely viewed in the context of higher education and academic research communities. So we were primarily concerned largely with scholarly texts, journal literature, thesis, technical reports, such documents. Today, it's a very different situation. Large corporations and even governments and policymakers have begun realizing the importance and economic value of information and knowledge. The nature and medium are very different today, varied. For example, over 80% of enterprise content, if you take a large corporation like Infosys or Google or Microsoft or TCS, whatever it might be, over 80% of enterprise content generated within the enterprise is unstructured, but it has immense value for the enterprise, and therefore systems should be capable of categorizing this and retrieving this, analyzing, extracting useful information in thousands of memos, emails, internal reports, videos, etc. is a very, very difficult and huge task. Therefore, there are major points of departure between requirements of information retrieval today and what was, in Ranganathan's time or during much of the first 3/4 of the 20th century. The approaches to information retrieval till the middle of the 20th century and even to a certain extent the till 1960s and 70s dealt largely with structured, semi-structured data, formal channels of communication such as books, journal articles, thesis, etc. Today, information retrieval must look at means to overcome information in the form of unstructured data of all kinds, tables, for example. Therefore, the current concerns are not about arranging documents, information objects to support browsing and recall. The main concerns are how do we automatically categorize, because it is practically impossible to think in terms of manually categorizing a large, think of 10,000 stories being streamed in by writers and people trying to categorize. When a story is, first of all, you should be able to tell whether it relates to politics, sports. If it is sports, is it cricket or boxing or table tennis or what is it? So automatic categorization requires that the machine should be able to understand a text enough to identify entities, concepts, etc. associated with that particular text. Adequate description of information resources, labeling the items to automatically to support retrieval. Clear and more explicit specification of relations between concepts and entities to support browsing and navigation, if there is something else that is related to it. And the presentation of results in a logical order. Logical means ranking the search output. These are some major requirements. These systems, therefore, not only have to accommodate these requirements, but they should be capable of operating at the scale at which they need to operate to be able to do these things and handle the range of material resources from which to recall needed information, not just scholarly material, but also balance sheets, emails, hospital patient records, crime records, images, multimedia, video, etc. Rediscovering Ranganathan. In examining the relevance and utility of Ranganathan's ideas in the present-day digital environment, at least two separate issues need to be looked at. Digital libraries, in which the content is very similar to that found in conventional libraries, only the form is different. Digital journals, digital theses, digital books, etc., in place of print on paper material. New requirements necessitated by developments in the digital age, information and knowledge. So, if we consider the first one, Ranganathan's ideas are as applicable and relevant to this situation as in a conventional library environment. The use of notational library classification systems will largely be restricted to libraries, though many databases continue to use broad classes represented by notation. Most of them continue to use some form of notation, although this notation is pretty brief. As I mentioned earlier, information retrieval today is based largely on matching techniques, measures of popularity. There are questions about the utility and adequacy of this approach. I will not go into details of this for want of time, but there are questions about these are susceptible to vocabulary mismatch. However, given the volume and rate at which new information resources are being generated, there is no escape from automated text-based indexing. Ranganathan and others dealt with semi-structured data, formal channels of communication, requirements of arranging objects, records in a classified file in a logical and helpful fashion. That was the primary focus. Specialized information retrieval situations requiring high precision will most likely adopt new approaches, new technologies such as ontology for knowledge representation and management. Progress in artificial intelligence to enhance the machine's ability to understand and analyze natural language texts to categories and metadata extracted automatically from text will be extensively relied upon for indexing and retrieval. Does this all mean that the theories and techniques developed by Ranganathan and others are no longer relevant? Way back in 1978, Dr. Dahlberg wrote a paper in Advances in Librarianship. The paper was on developments in classification, and it started with the paragraph section heading, No Developments Since Ranganathan. 50 years later, almost 50 years later, if we look at theoretical aspects, there is still no other major development that can be compared with what Dr. Ranganathan has contributed. One should not merely look at Ranganathan as designer of colon classification. It's important, and people have found applications for techniques in building tools for the digital age. David Weinberger wrote in Forrester in 2012, it is as if Ranganathan designed his classification in 1933 specifically for the kind of instant reshuffling that computers made feasible decades later. Steve Pappas, one of the co-founders of Endeca, uses Ranganathan's ideas in its software. He says facets are all about manipulating multi-dimensional space. You cannot do that in the physical world, but Ranganathan was ahead of his time. The constraints of the physical world did not inhibit his imagination. Mustafa El-Hadi quotes Catherine Laber is one who has done considerable amount of work on facet analysis. Her thesis, PhD thesis, she mentions that information architects seemingly discovered a legacy from information organization and access, faceted analytico-synthetic theory, FAST, which is consisting of a set of principles and techniques to organize information. Now, this is being looked at by information architects in design of web pages. Incidentally, even the Library of Congress is looking at facet analytico-synthetic facet approach to redesigning its thesaurus, Library of Congress subject headings. So this exploration of connections between the intellectual foundations of information organization, much of which was Ranganathan's contribution, and current practices, designing thesauri, web design, looks to past heritage for guidance to current practices for evidence. In conclusion, I would like to say that Ranganathan's 5 laws, normative principles, and facet analysis continue to serve as a blueprint for the profession and are as relevant today as they were when they were formulated. Thank you all very much.
Thank you, sir, for such an illuminating speech, and really academically very enriched. You started your journey from chain indexing and ended with AI/ML applications on the basis of Ranganathan's theories and practices. a really great experience for all of us. Now we are almost at the end of this auspicious day of National Librarians Day 2022. And may I ask now my colleague, Dr. Deepa Rai, presently in charge of the Central Library, to provide the vote of thanks, to extend the vote of thanks to our honorary speakers, to our beloved Vice Chancellor, sir, and all the delegates from all over India who joined here in this particular occasion. So, Deepa, may you?
Thank you, sir, for giving such an opportunity. Firstly, I would like to thank who is a true lover of the library. Hello, may I audible?
But echoing is coming, so possibly you have entered with two different locations. So one need to be stopped. Okay, let me check.
Firstly, I would like to thank our Honorable Vice Chancellor, Professor Manush Sannal, who is a true lover of library, for providing his support and permission to organize this international webinar to celebrate the Librarians Day. He has steadfastly supported the thorough renovation of the Central Library since his arrival. I would like to thank Professor Carlo Bianchini for his valuable keynote address on colon classification in WikiData Environment. So nicely, he makes us understand how to formulate facets of the work of the regional language based on colon classification through CCLitBox, a WikiData gadget for automated faceted classification. Next, I would like to thank Mr. Demian Katz for his talk on search versus discovery. He makes us understand what is VuFind, how discovery feature can be integrated into a search result, how VuFind works search system with the classification and discovery mechanism. I would like to thank Professor K.S. Raghavan on his talk on rediscovering Ranganathan. He thoroughly makes us understand the relevance of Ranganathan works in the present day context, that is in the age of computer, in the technology, in the online information. The keynote address and the two talks highlights how relevant the Ranganathan works remain. The classification system was first introduced in 1933, and it is testament to the timeless of Ranganathan ideas that we still to explore the theory and application of faceted classification. Finally, I would like to thank all the current and the future librarians to follow the footsteps of the Ranganathan, as the author Neil Gaiman and answer, a librarian will bring you back the right one. Happy Librarians Day. Thank you, sir. Thank you, all of you.
Thank you, Deepa. So it's time to say goodbye to each other. And we are really grateful that Professor Bianchini has spent the entire time with us. And sir, we expect that in future we'll be maintaining a good academic relationship between the Italian group who are very much interested in Ranganathan theories and practices, and we will form a group of like-minded people who are really interested to apply Ranganathan theories and practices in the present day's AI/ML dominated scenario. So a very best wishes to all of you on this auspicious day of National Librarians Day 2022. And with this, we say goodbye and expect that we will be getting your support in future also. So goodbye, sir.
Goodbye, all of you.